Hey guys, it's Miss Johnson. Welcome to the first asynchronous video of this week. It's about distance graphs. So we just finished up learning about piecewise graphs and piecewise functions. And you might notice that this one, if we wanted to represent it with like written out functions, would need to be a piecewise function because there's some straight parts, there's some curvy parts. It's continuous, but it's not represented by one like nice function. This is what a lot of distance graphs are going to look like. I mentioned it last time about how when we walk, it's not always just in one direction at a constant speed. We're doing a bunch of stuff, turning around, stopping, slowing down, speeding up. So when we graph a distance graph, it's going to look a little bit wacky. Let's look at this one. I've written one up just that has a lot of interesting twists and turns, so we can kind of tease it apart and figure out what's going on here. The first thing we want to do is look at the axes. We always want to look at our units. We want to look at what is this graph even saying, right? So on our x-axis, which is now our t-axis, it's time. So when we go from left to right, we're thinking of minutes passing. So at this point, 5 minutes have passed. Let's get rid of those. At this point, 10 minutes have passed, etc. And then our y-axis, which is now our d-axis, is going to be for distance traveled. And it says in miles. Honestly, I'm not even sure if this minutes miles works out, if we're super slow or super fast, but that's how it is. So for this particular distance graph, the origin means there's been 0 seconds and you're 0 miles away from some landmark. Let's say Garfield High School. So we start, if this is like a walk we take during lunch or something, we start about half a mile away from Garfield. Pretend that's where you live. Then you walk for about 4 minutes, right? At a constant speed until you're 2 miles away from Garfield. Okay. And then from 4 minutes till 6 minutes, our distance doesn't change. We don't go up or down on the graph. We just go left to right. So if your distance doesn't change from 4 to 6 minutes, that's kind of just you're taking a break. You're just like sitting there. You're not getting farther away from Garfield, but time is passing, right? And then our distance goes from 6 minutes to 9 minutes. Our distance was at 2, and then we dipped down to 1. So maybe we forgot something and we turned back at Garfield, right? So like maybe we dropped our wallet. We have to go back a mile, pick it up. And then from 9 minutes to about 14 minutes, we are walking away from Garfield again. Now we're 3 miles away at this point. And then again, from 14 minutes to about 18 minutes, we're not getting further or closer away from Garfield, so we must be stopped. All right, and that's kind of how to interpret this distance graph. I've got a few questions we're going to list through and work together. Feel free, I'm going to read the question. Feel free to pause the video, think about it for a second, try to guess what I'm going to say. As just a way to, stay engaged and thinking while you're watching the video. And then you can unpause the video and listen to my explanation. Okay, so number 1, how much time did her walk take? It says her because I was thinking about it as me, but feel free to fill in your own pronouns. How much time did Miss Johnson's walk take? Pause. Unpause. These are going to look really silly if you don't pause them. Yeah, well, I started at 0 seconds, and then the graph ends right above 18 minutes, or 0 minutes and 18 minutes. So the walk took me 18 minutes. Okay, cool. How much total distance did I walk? Did Miss Johnson walk? Well, I started at, let's say, 0.5 miles. And then I walked till it was 2 miles. So that was 1.5 miles. I did my little rest. I walked back a mile to pick up my wallet. Then I walked 2 more miles until I hit the 3 miles away, right? So let me color code what I'm talking about here. Color yellow. I started here. Then I went to this point, so that was 1.5 miles. I went from here to here, which was 1 additional mile. Then I went from here to here, which was 2 additional miles. I did say 3, so I'm glad we checked our work. Boom. Okay, so the total amount that I walked was 1.5, 2.5, 4.5, 4.5 miles in 18 minutes. Yeah, wow. I'm in the wrong profession. I should be an Olympian. But here we are. Okay, next question. Doop, 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 doop. How far from my starting point did I end? Okay, so let's draw all over this graph again. I started 0.5 miles away from Garfield. I ended 3 miles away from Garfield. So I ended 2.5 miles away from where I started, because 3 minus 0.5 equals 2.5. And we might notice, you might say, Miss Johnson, what? You walked 4.5 miles, but you ended 2.5 miles away from your starting point. It's because I turned around at some point, right? My Fitbit is going to say that I walked 4.5 miles. Someone who saw where I started and ended is going to say you only changed your position by 2.5 miles, which is true. And then, did I ever stop? Yes. Yes, I definitely did, right? Whenever the time is moving forward, but my distance is not moving forward, I've stopped. And there's one other place we stopped, so, let's write these down, and then I'll talk about another place that I stopped. So I stopped from 4 minutes to 6 minutes, and I also stopped from 14 minutes to 18 minutes. The other place I stopped, and this is going to be a little bit wacky, was right here. And let's talk about this for a second. If I was moving backwards, moving closer to Garfield, and then turned around and moved further away from Garfield, there is a nanosecond, a split second, an instant that I was not moving. Right? So I don't know how big this webcam is, if I can make it bigger. Oh, big mood. Okay. So if I'm going to walk forward and then start walking backwards, there was like an instant where I was walking forward. I had to completely stop my velocity in order to move it backwards. So at this very bottom point, at the vertex of this parabola looking thing, is a split second where we stopped. So I'm also going to write down, and right at 9 minutes. Oh, just kicked something. Okay, so those are the 3 times I stopped. These ones were to take a break, right? The intervals where I stopped was to take a break, but the split second that I stopped was because I was turning around. Okay. Next thing to talk about. Did she only walk in one direction? No. Right? We talked about how I turned around to get my wallet or whatever. So basically, whenever the graph is increasing, we can think of this as moving forward, right? Because we're getting further away from Garfield. Whenever the graph is decreasing, we're kind of moving backwards because we're moving closer to Garfield. And then whenever the graph is flat, that's a stop. That's where I'm stopping. So where are the points where I changed directions? Well, I definitely changed directions right here at 9 minutes. And then we can kind of say, like, during my break, I also changed directions, right? Because I was going forward from 0 to 4 minutes, and then from 6 to 9 minutes, I was going backwards. So at break, that's not even great handwriting. At break, during 4 to 6 minutes. Okay, so that is that's kind of the things that I wanted to at this moment point out about this graph nitty gritty. The other last thing I wanted to talk about is what if I hadn't dropped my wallet and didn't need any brakes and was just doing what I was saying, like moving forward at a constant speed, right? And this is where we're going to say, Laura, you can't draw. Oh my gosh. If we were drawing a graph of me just going straight from my starting point directly to my end point, it would be a straight line, right? Here we go. Drawing a picture. Not too bad. All right, so if I were going a direct route, it would just go straight from 0.5 to 3. It would start at 0 minutes. It would end at 18 minutes, right? And then I say, okay, how fast would that have been? What would be the velocity? Okay, velocity is usually like miles per hour. Here it's going to be, oh, that's supposed to say minutes. All of these are supposed to say minutes. It's supposed to be distance over time, right? Velocity is distance over time. We've heard that a lot. So the velocity of the direct route is, okay, my distance that I actually traveled was 2.5 miles. And the time it actually took me was 18 minutes. If I had done, my entire route was just from my start to my end, and I still ended at the same time. Which ends up being, let me get my calculator out. Calculator, 2.5 divided by 18. Wow, I am flying. It's 0.13 miles per minute. I'm very fast, faster than just absolutely everyone. Yeah, so if we did a direct route, that would be the velocity. A fun fact, let's do a fun fact color. Fun fact. The velocity of the direct route was our average speed for our actual graph. So velocity of direct route is equal to, and let me move this, boom, is equal to, goodness, average velocity of our route. Not factorial. Cool. So that's kind of what I want to tell y'all about distance graphs. You'll have some work where we draw our own distance graph and then answer similar questions about it in your group. But for now, that is that. All right, guys, email me or come to the office hours if y'all have any questions. Thank you. And then I turn off this picture somehow.